You can see the coil dimensions on the screen. The coil length is 300 millimeters. The internal diameter is 50 millimeters and the external diameter is 100 millimeters. There is no core inside the coil. The coil carries direct current of 1 ampere and consists of 7,500 turns. You know that in the long solenoid the field is uniform, so let's take a look how this coil should be simulated and check the field distribution inside the coil. So I start the QuickField. Here I have the problem. The problem type is magnetostatics, as the coil carries the direct current. The model class is axisymmetric. The coil features cylindrical symmetry, so only upper half of the coil is represented in a geometry model. There are 3 objects in the model. First I have the air. For the air I specify the magnetic permeability of 1. Then I have the coil. The coil consists of 7,500 blocks. You can see that each turn is represented by the separate block. For the coil, I specify the magnetic permeability of 1 and the field source the current in the conductor. And all the currents, all the conductors are connected in series. And I have the external boundary. Let's take a look at the field distribution. I will switch on the color map of flux density. You can see indeed there is the region with uniform magnetic field inside the coil. And using the field picture you can estimate the size of this region and the flux density value. Multi-turn windings are often simulated by one loop with large cross-section and uniformly distributed current density instead of simulating all individual wire cross-sections. This led you to simplify the model. So let me show you. This is the example of the same coil, but the coil is represented by the solid block, only one block. And for the coil I specified the total current, the ampere turns, 7,500 turns per 1 ampere. Let's take a look at the field distribution. Again, I will switch on the column map. And adjust the picture so you can compare. By the flux density value, you can guess that I get the same results. So this is the fast way to simulate the coil. You can draw in the model every turn, or you could draw the single block and specify the total current. The flux distribution produced by the coil will be the same. Please note that you cannot use this approach if you want to calculate the induced voltage in the winding.